You know, creating an AI that can actually reason its way through tough problems isn't some kind of dark magic. It's actually a lot like cooking. It's all about having the right recipe with the perfect ingredients and a really specific method. So let's dive in and break down the exact recipe that's teaching AI how to think.
All right, so this is the million-dollar question, right? We're not talking about an AI that just memorizes and spits back facts. We're talking about one that can solve math problems it's never seen before, or write brand new code. How in the world do you get a machine to go from just processing information to truly understanding it?
And what's so fascinating is that the answer isn't just about throwing more and more computing power at the problem. It's actually much more subtle than that. Thanks to some incredible breakthroughs, a lot of them from the open source world, we're learning that the secret is all about a carefully crafted recipe for data. So let's get into it.
Okay, part one, the secret recipe. Every amazing dish starts with the ingredients. And for an AI, the ingredients are the data it learns from. Getting this first part right, choosing that perfect mix, is absolutely critical. So the first step in our recipe is something called supervised fine-tuning, or SFT for short. The easiest way to think about it is like giving the AI a perfectly written textbook. You're showing it tons of high-quality questions paired with perfectly solved answers so it can start to see the patterns of what good reasoning looks like.
Now here's a thought. Your intuition would probably tell you that the more data sources you use, the more diverse your ingredients, the smarter your AI is going to be. More is better, right? Well, is it?
But check this out. This table just blows that whole idea out of the water. Researchers found that when they were training a model for coding, using only the top 2 best data sources gave them the highest score. But look what happens when they start adding more sources. 4, then 8, then 16. The performance actually gets worse. It's a wild discovery, and it screams one thing loud and clear. It's all about quality, not quantity.
All right, here's another assumption for you. If you're going to use an AI to generate examples to teach another AI, you'd pick the biggest, baddest, most powerful model to be the teacher, wouldn't you? I mean, it just makes sense. The smartest teacher should make the smartest student.
Yeah, well, think again. The data tells this bizarre, counterintuitive story. In this head-to-head, a smaller, weaker model actually turned out to be a better teacher. The model it trained scored significantly higher than the one trained by the stronger AI. It suggests the best teacher isn't just the most powerful one, but maybe the one that provides the clearest, most helpful examples for the student.
And just to cap it all off, the research showed that even when they tried to filter out the bad answers from the training data, it didn't really help much. It was often better to just leave everything in, mistakes and all. So the big takeaway from our ingredient list is that this recipe is way more nuanced than we ever thought.
So, once we have our fancy ingredients, it's time to actually start cooking. This is the stage where the AI moves beyond just studying examples and starts learning by doing, by trial and error. This is how we perfect the actual cooking method. And this next stage is all about a technique called reinforcement learning. If that first step, SFT, was like reading the cookbook, then reinforcement learning is when you're in the kitchen, tasting the sauce, and adjusting the seasoning. The AI tries to solve something, it gets feedback, and it learns to do a better job next time.
Here's basically how that cycle works. First, the AI will just generate a whole bunch of different answers to the same question. Then, another AI, you can think of it as a judge or a taste tester, scores every single one of those answers. The correct ones get a high reward. Finally, the main model gets updated, tweaking its own programming to be more likely to generate those high-scoring answers in the future. It's a constant loop. Try, get feedback, improve.
And does this extra step actually work? Oh yeah, it works big time. Just look at this chart. That light orange bar, that's the performance after just the first step. The darker bars, that's what happens when you add this learn from your mistake step. On AMY 24, a really tough math competition, the accuracy jumps from around 65% to over 70%. We see this again and again across all these hard tests. A solid 5 to 10% boost in accuracy.
So we have our ingredients, we have our cooking method, now it's time for the final bake-off. This is where we put these new models to the test against the best of the best, to see how good this rescue really is.
So how big of a difference does our recipe really make? Well, think of it this way. A base model, before all this training, is like a plain cupcake. It's fine, but after you apply this 2-part recipe, you get something way more impressive. On a really hard math test, that base model might score a respectable 65%. But with our recipe, that score can leap well into the 70s or even the 80s.
And you can see it right here in a direct face-off. On that Amy 2024 math benchmark, a model trained with these techniques scored an incredible 86.7%. That's just blowing past another very powerful model. It really shows how potent these new recipes are.
Now this is the part that gets really exciting. These incredible recipes aren't being locked away in some secret corporate vault. This model, OpenThinker 3, achieved a state-of-the-art 53% on an even newer benchmark, and it was trained on a completely open-source recipe. The kitchen is officially open to everybody.
So what's the big picture here? Well, just look at this leaderboard. These new reasoning models, the ones developed out in the open, are seriously climbing the ranks. They are closing the gap with the proprietary giants like GPT-4 and Gemini. The whole field of AI is becoming more competitive, and that is just accelerating innovation for all of us.
We've gone from the ingredients to the method to the final taste test. So what have we learned? And what does this all mean for what's next on the menu for AI? So here's the recipe one last time. First, quality over quantity with your ingredients, always. Second, the best teacher isn't always the most powerful one. Third, you've got to let the model taste and adjust by learning from its own mistakes. And finally, and maybe the most important part, the kitchen is open. These recipes are out there and it's leveling the playing field.
And this is really just the beginning. As this quote from a recent paper hints, we're still figuring this out. With more computer power and more fine-tuning, the feeling is that these reasoning abilities can be pushed way, way further. We haven't perfected this dish just yet.
Which leaves us with one final fascinating question. For years, the secrets to building top-tier AI were closely guarded. But now, the recipe for reasoning is becoming public knowledge. This completely changes the game. So, who's going to use it to cook up the next world-changing breakthrough? We're about to find out.